Hello, today we're going to talk about domain and range with interval notation. Alright, for our first example, we just have a regular linear function. I wrote all of this up there to remind you of the open circles, closed circles, brackets, parentheses, everything else. So here, I just have a normal linear function. So, the domain here is the x-axis. So your left and right, east and west. Now, since they have arrows at the very end of both of them, what that tells us is it's going on forever and ever in those directions. It doesn't stop. If there was an open or closed circle, that means it stops, of course. So where is this one right here going on to the right? It's going on forever and ever, or infinity. And it's always a closed, or it's always a parenthesis in this case, because you can't actually get to infinity. So now we're going left. All right. Now this is always going, and it's going and going and going forever, down this line forever and ever and ever and ever and ever and ever, till it reaches, or for negative infinity. It will never stop going in that direction on the x-axis. Now where people usually get messed up here is you start thinking about the y-axis. Think about it in two separate sections. The domain is just the x-axis, and then you have your range, which is your y-axis. So you have to look at this two different ways. So now I looked right and left, east and west. Now I look north, south, and up and down. So where's this one going in that direction? Up. It's going forever and ever, correct? So it's going forever and ever in the positive direction. It won't stop. And now which way is it going down? Does it have any indication that's going to stop? No, it's going to go forever and ever down in a negative infinity. Now you might ask yourself, why did I put the negative first? You always put the smaller number first in interval notation. So negative infinity is the exact opposite of infinity. So infinity will always be over here. So whenever you have a linear function that doesn't have like a piecewise or something, or something in it that says I can't do it. So if I erase this section and said, or no, I kept that, and I erased this and put a dot there, it's always going to be negative infinity to infinity and negative infinity to infinity. That's all linear function is. It goes forever and ever, north, south, east, west, and it always goes to negative infinity, infinity. Now, since I went ahead and did that, we're going to call this b. We're going to stick with the linear function with our interval notation. So our domain now is different. Why is it different? Because it stops now. Okay? Actually, I'm going to put it, that'll be fine. So, my domain is new. Where does my domain start now? My domain starts, because we're only talking about the x-axis, at 1, 2, 3. So my domain starts at 3. Now what am I going to put around this? Because it has to have either a bracket or a parenthesis. Alright, it's a closed dot, so I'm going to put a bracket around it to say my domain includes 3, which is right there. Now where is it going to the right? Forever and ever it is going to positive infinity. And that is how you write your domain in interval notation. Right? This takes some thought. Now let's look at our range. The range again is the y-axis, so up and down. Now, where does my y start? It starts right here. 1, 2. Now what am I going to put around it? It's a closed circle, so I'm going to put a bracket. Alright, now where is it going to? It's going in the positive, this is positive up here, this is negative down here. going in the positive direction forever and ever. So positive infinity. So those are two examples of a linear function writing it in interval notation. This notation is when it's just a regular linear function going on forever and ever. This one has a barrier to it. In this case, 3 stopped it on its domain, and the range started at 2. Notice my smaller number is always first. 3 is much less than infinity. 2 is much less than infinity. I'm going to do one more example, and then we'll move on to another one. All right, now we have a different line. All right, it doesn't continue forever and ever. It stops somewhere. Where does it stop at? On the domain. Remember, the domain is the x-axis. I can't stress that enough how many times people get this wrong because they look at this as the y. The domain is this. Just forget there's an up and down. So it starts at -1. Parenthesis or bracket. It's an open circle, so I put a parenthesis around it. Now where is it going on the domain? Forever and ever, it's going in the negative direction, so it's going to negative infinity. And negative infinity or infinity always has a bracket with it. Now the range. Now we're dealing with the y-axis. Where do we start on the y-axis? 1, 2, 3, 4. Bracket or parenthesis? Bracket, because it's an open circle. And where is it going? It's going in the negative infinity direction forever and ever. And there you go. That's how you do it if it has an open circle. Now we're going to make a change. All right, so now, what is domain of that new image? Now this is just a line segment. So where does it start from? It doesn't matter, I'll start from here, because I know it's going to be my last one. So 1, 2, 3, 4, 5, 6, 7. It starts at -7. I have a closed circle, so that means I put a bracket around it to mean it includes -7. And where does this go to on the domain? Well, we already know it goes to -1, and it does not include it because it's an open circle. So this line segment is saying, all right, all the x's from -7 to everything before -1 is included with this domain. So is 0 included? No. Is 10 included? No. Is -1 included? No. All this domain is saying that these are all the x's that are included in that line segment. Now we need to find out which y's are included by finding the range. So on the range, which numbers are included? So let's start down here. That's -1, -2. So it's starting at -2, and it includes it because it's a closed circle. And then it goes up to 4, and does not include it. Man, I wrote this one wrong. See, I wasn't thinking. But now, I got to think to go look back at it because I knew my smallest wasn't there. Always go back and check your work. Your smallest always has to go first, every time. So you haven't messed it up. You just have to go back and check your work and think. And that's how you do that. And I'm going to show you one more different example, but it's for later. All right, this image is called a parabola. Right? It goes with quadratic functions. I want to know what its domain is. All right? So as I'm looking on it, I look to the left arrow. Where does this arrow go? All right? Forever and ever, it's still going in the negative infinity direction. Which way is this arrow going? In the positive infinity direction forever and ever. because there's, no, that's just how I used to draw it, sorry. It just keeps going, forever and ever. Now, the range is something different. Now, where does the range begin? The range begins at 1, 2. And it includes it. And it goes to infinity. That's for the second part of the year. Alright, this has been domain and range and interval notation. Sorry about that mess up with the putting the smallest one first. Make sure you always put the smallest one first and just go back and check your work like I did. I did it wrong at first, then I went back and checked it. I'm not gonna change my video when I mess something up, just so I messed stuff up too. So there you go. Good luck.